Looking at page IN16, we are continuing our lesson on comparing and ordering real numbers. So on page IN16, we are going to look at number 7. Compare and order the following numbers from least to greatest. So like we've talked about before, what we're going to want to do is get decimal approximations for these. Once we've got them as decimals, then we can compare, put them in order from least to greatest. Two of these, the first two are already as decimals, so we just have two of these, the last two that we need to change to decimals. And then try to remember when you're writing these, we need to use the original numbers, not our decimal numbers that we've created when we rewrite this. So this third one, the mixed number 3 9/10, oh, that would be the same as 3 9/10 as a decimal, okay? Square root of 21, again, if we're allowed to, we could use a calculator to figure that out. Otherwise, we could kind of guess where it's going to be. I mean, really, I probably have enough information here that's in between the square root of 16 and the square root of 25. Square root of 16 is 4. Square root of 25 is 5, so it's going to be 4 point something. With the numbers they've given me, that's really enough information for me as it is. It's like 4.58 or something, but anyway, 4 point something for this problem is enough information. So now we're just going to put them in order from least to greatest. Just remember, if you have negative numbers are the smaller numbers, so they will come first. So this problem, there's only one negative number, so it's going to be negative 5.6 repeating. If you want to cross it out, if you want to do something to indicate, underline it or something to indicate that you've used that number so you don't accidentally use it again. So now if we look at our positive numbers, the smallest positive number, look at the whole number parts, 5, 3, 4. 3 is smallest, so that's going to be the smallest one here. 3 9/10, and remember to write that as a mixed number, 3 9/10, because that was what they originally gave us. Square root of 21 would come next because 4 point anything is less than 5 point anything, and then that would leave us with our 5 2/10 loss. Always make sure when you write your answer that you have as many numbers there as there was in the original problem, and we are in good shape here. So we're going to look at a few problems here. These are not in your book, so don't be looking for a workbook that this is in somewhere. We don't have another workbook that has these, so you'll just have to follow along here. We're going to start with number 2. So they want us to find the rational approximation of the square root of 37. And it says approximate using perfect squares. We're going to go with the assumption for this problem that we cannot use a calculator. And I'm going to eliminate their first line here. If you want to write it, you can, but I think we can just have 2 lines and get our answer okay. So the first thing we need to do is try to figure out some perfect squares that are close to 37. So a number times itself that's close to 37, where that if we would take the square root, it would come out evenly. So think back to your multiplication facts, and somewhere in there, 6 times 6 is 36, and that would be just slightly smaller than that. And like I said, if that's 6 times 6, then the next one up from 6 would be 7. So 7 times 7 would be 49. So that's square root of 49. So then that brings us to our next line. We could say square root of 36 is 6. Square root of 49 is 7. And then what we're doing really is looking at whether 37 is closer to 36 or 49. Some of these are close calls sometimes. This one maybe not so much. So this one's definitely closer to 36 than it is to 49. And then that means that our answer is closer to 6. So it's between those two, but then we could say it's closer to 6. Technically, by the answer they're giving me in the book here, they just have that and that's it. But I think it might be valuable for us to know to the nearest whole number what it is. So now we're going to look at number 5. they want us to list these in order from least to greatest. So we did a similar problem not very long ago here. So least to greatest, once again, let's get these as decimals if they're not already, and then we can put those in order. So to start with, the square root of 5, again, for speed's sake, if we did that on our calculator, it's about 2.23. 1/2, you guys might know, is 0.5. I mean, it's technically 1 divided by 2. You could divide it out, but half is 0.5. And then negative 9/4, we divide that out, would be negative 2.25. So at this point, we have all decimals. Now we'll be able to compare. Again, starting with negatives, the most negative number is going to be our smallest number here. So negative 4 is our most negative number. That's going to come first. We only have one other negative number. You might look at it as negative 2.25. Remember, it was negative 9/4 first, though, before we changed it. And then next would be 0.5, which was 1/2 to start with. And then next would be our 2.23, which was the square root of 5. And then that leaves us with 3 7/10. So this would be our order least to greatest. So again, the key on those just is really getting them all as decimals and then just putting them in order from there. All right, so next we look at number 9. They want us to put these in order from least to greatest. Before I even start messing with a calculator, if I can use that, one quick thing I can do is just make a couple observations. So like on A, see how we got a 5.2 and then we got a 4 2/3. We're going least to greatest. Is that going to work? Nope. Okay. This one, they're in the right order. This one, they're in the right order. This one, are they in the right order? No. It's already a 50-50 chance just by me knowing 4 and something is less than 5 and something. And then B and C, let's look at the square roots for a minute. Square root of 17, square root of 32. Which one's smaller? So square root of 17 smaller. Whatever, if there's a smaller number under the radical there, if we're doing a square root of a smaller number, it's going to be smaller than the square root of a bigger number. So really, even just without even working out any decimals or anything, we can figure out the answer is going to be B. Okay? Number 10, area of a square frame is 55 square inches. Find the length of one side of the frame. So what we can do is start out with, it's the area of a square. To find the area of a square, we can do length times width. On a square, well, first of all, if we take that formula, we know our area was 55. And then if we think about this, really we're thinking of two things we could multiply together to get 55. But it's a square, so, they have to be the same as each other. So that sounds like something we've been talking about in this lesson. So a number times itself to equal 55, a number times itself to equal something, we can do the square root. Square root, figure out the side of a square frame. So square root of 55, and it says, part A, it says to the nearest whole inch. So that one we could probably just think out by hand ahead of time. Perfect squares. Let me come down here and give myself a little bit of room. Square root of 55. So square root of 49 is pretty close to that, a little bit smaller. That's 7 times 7, so this one should be 8 times 8, which is 64. And then we're just looking at the differences here. So from 49 to 55, that's a difference of 6. From 64 to 55, that's a difference of 9. And so it's a little bit closer to this one. So it's nearest whole inch, that would be 7 inches. It would be closer to, again, based off of this here. Okay, closer to 7 inches. And then the last thing is on part B, they want this to the nearest tenth of an inch. For time's sake, we'll just use a calculator here. We do know it's closer to 7 than 8, so it's going to be less than 7.5. It's got to be either 7.0, 7.1, 7.2, 7.3, or 7.4. So if you did that on your calculator, again, for time's sake here, we get about 7.41, and so the nearest tenth would be 7.4. So 7.4 inches would be our answer for part B. So this gives you an idea about how to compare and order real numbers.